Hello, this is Junchan. Welcome to the stream. We're back to do some more Comonad related stuff. Last time was mostly talking and looking at papers and kind of gathering thoughts and gathering lots of thoughts and lots of potential way forward. But we'll try to be a little bit more practical today and go back to our code. And there's several ways to do that. And first of all, what is our code? Our code is this guy, our Comonad composition proof of concept, the POC. The idea here is to try and get this Comonad approach to UIs sort of in the right shape for the other things we'd like to do with composing maybe other Comonads with it, as well as being able to make it so that interpretation of our Comonad can also lead to monadic effects, and that we can use IO or effect in PureScript as a vocabulary inside our Comonads. And so this journey into figuring out how to add monadic actions to Comonads maybe doesn't start there, but sort of takes a lot of not this one. Takes a shape that is important to the conversation, which is this extensible coeffects, which led us in some of the previous streams to look into other definitions of coeffect and be inspired by Thomas Petrichek's coeffect and context-aware programming languages, but basically also trying to get more familiar with the territory generally. And with this POC, one of the ways that we've been moving forward is exactly with the coeffect definition as Phil Freeman uses it, which is really, if you'd like to, it might not be exactly coeffect as described in the Thomas Petrichek's thesis, but it's really exactly about the problem I was describing before, which is how do you stick some base monad inside a Comonad or a Comonad transformer stack. So we can do Comonad transformer stacks, but how do we squeeze in a monad in there? And the reason for that is that we'd like to model some spaces using Comonads, like for instance maybe databases, maybe cursors into lists that might, or cursor into bits of space that might have some things that are held into memory when they're focused, and things that might need to be fetched from a persistent source if they are when we move the cursor, for instance, which is what the apart Comonad does, and we've looked at in previous streams as well. So if we want to do that thing, if we want to be able to load up some persistent data from disk or the network inside our Comonad, then we need some way to run effects into IO. Or there's another approach, which would be to say run effects into IO inside our Comonad definition. And that's a little bit the approach I think that Coty does, by wrapping an M inside a co-free. Okay, that's what Coty does, and specifically for the co-free Comonad, does this by layering an M around each of the iterations of the co-free construction, and then trying to then use Coty with that, with the M being wrapped around the original, the F base functor and the recursion here, but the M is also for some reason present in the type parameter of COT as well, which means that there's an expectation that we return a value potentially in R. So you know what? The more I look into this, the more I'm thinking maybe these are the two things that this is doing. One thing is, because it uses compose effect, it allows us to use effects inside the comonad, which I suppose is always an option, but maybe we don't want to do that. Maybe we just want to be in the pure comonad and not take advantage of our capacity to do effects, which means that ink will look more like this without the compose. And so in fact, I'm going to swap those two. Okay, and effect here, however. So in this case, I have change and ink living in the COT comonad transformer, and meaning they can. So how I interpret what that means is that they might be interpretable in MR, but they themselves can't include an effect, which I like. I prefer that. I prefer that the interpreters or really it's not even the interpreter. It's sort of the automatic-ish derivation of the interface into a monadic action. And I think there might be a way to do this more in a more principled way. Automatically, I'm not sure, but possibly actually. But it's not too difficult. Yeah, I think we could now use lift. Do we even need to lift coef? I'm not sure whether we're going to need to use this, but anyway. Okay, so here we now need to change how we think about interpreting. And so let's refactor this. So one of the things that I was saying last time is that I think that maybe we don't want to pass the interpreter down there. In truth, what I said is that we didn't maybe even want to pass a monadic thing at all in here at the component level, because we might actually want to just pass it maybe into the maybe a level higher, such that component is maybe stays pure, and then that we pass an interpreter that will interpret it into maybe either again purely, or if we do marking, or into a effect for base monad like IO or effect, or AF or effect for us in pure script. But I suppose I'm going to try and unroll what might change to not have compose M leads to. It means, are we still going to maybe use this the free the wrap free instance? I'm not sure, but for now we'll thread the interpreter and we see where that leads us. Threading the interpreter means that, right, that in this case, the interpreter does occur in compose effect counter interface. So that might be a problem, right? We could rewrite this as effect of counter interface of counter model, and that would get rid of the compose here. I don't know if that helps, but we choose which interpreter we pass here, and then we use that. We pass it the count, and then that gives us the one or the other. And that tuple, based on the type of cofree, will give us this cofree FA, trying to weave the monad in there. And right away, I feel like that's a little bit too much complexity. I think we can probably just use explore M, which is sort of what the one of the conclusion I was looking at last time. So let's see, it would be here, explore M. So explore M, given that our component is in counter space, and that counter space is I think cofree of blah, we could pass component as one of the explore M arguments. Hold on, this I don't know, right, creates an MB, right? So we pass it as one of the arguments. Then except that we need to revert the AB and the cofree. So we need to have write the symmetric of this, and because our cofree, our component, is actually a component of handlers, which actually means that they are they're a component of an X to Y or an A to B. And then we pass it the free of A. So we have a cofree F, or cofree F FAB, and a free GA. And so the free GA is what gets passed into this explore thing when we do the run Qt here. It's the M. So that means that we need to rewrite explore here, and that's actually what I started to try and think of here. So what would that look like? This is the explore M that we're talking about. We know that we at least want to reverse it and have cofree like so, and so this will be explore M prime, and we might want to indeed say that this only requires pairing FG, and that this therefore can be done like so. And then we could then say that our new explorer, or explore prime, that we'd like to be of a similar shape, which are right, components. Right, okay. Yeah. So, interesting. So that's actually the other approach, is if I actually, you know what? I'm just realizing that what I said earlier is also wrong. I don't even need to have Coty in effect there. Because what I'm saying is that explore, that I'm using all the way down here, will now take interpreter. And the way we use send is going to be part of the trickiness here. Because that's what does this inversion of controls, but we don't really have another way to pass to pass control to the DOM here. We need to provide some kind of callback. So we won't be able to change that, I don't think. So it means that we won't really be able to provide a, I think I need to return here to co w unit, and yeah, passing the free GA here is going to be what's tricky. And it relates to the particular role that this modify state plays in advancing the state, specifically here. Let me see if I haven't mangled all of this too much beyond repair. That might not be the right one to check. So I might need to open up another experiment. The PureScript React Explore, actually, just that guy. It should be fine. And we want to check Explore here. And Command W, yeah, okay. That's correct. Okay, so maybe we take the pretty version and we comment out the documented version. So the problem is that we have this callback in the component that uses send to trigger, well, we have this callback that's basically, we have a DOM event. It's calls the callback, calls the callback, sends whatever we want, which is this monadic action, like M, and then that M, then arguably that's explore M in the middle, and then that's advancing the comonad. So it's returning the next comonad, and then somehow we write that to the React state. And then that goes to the DOM. And even with extract state send, I think we are reattaching the next send, right? The send that will do the modify state and advance things. So we're doing this kind of CPS style transform kind of all the way, right? The component once the callback is called by the DOM event, actually gets its send function called, which then means that the comonad gets executed in it gets passed, it's free only at this point, and that results in an effect. But since we use like extends const, I think that basically means that we're getting a co-free at the end. We're getting the next co-free, ready to wait for the next state. Yeah. So the fact that this control flow is hidden inside these CPS style transforms is not pleasant. Okay, I'm thinking about something right now. The pure script event library, this guy. In theory, we can make an event with this that will be called by that we can install into the DOM somehow, and that then when it gets called will actually output an event. I mean, this is, I mean, I remember trying this, and well, first I remember trying it and understanding it, and then trying it again and not understanding it anymore. Also, I thought that Halogen had moved to use FRP events, but then I think it's something that actually ended up being rolled back, unfortunately. And how can I see that it's been rolled back? I can see by think saying FRP event here. Well, there we go. And it's been changed to PureScript are already archived. PR migrates the code to allergen subscription instead. So it's not that it was deficient in any particular way, right? Let's look at what allergen subscription look like. Yeah, it looks like pretty much the same, right? It uses a different vocabulary, has maybe more utility functions. It's actually it's in its own library. Push-based subscription inspired by the event library can be used independently. So yeah, we create a subscription. It gives us an emitter and a listener. We then subscribe to the emitter with a callback. And then when we use notify, I suppose we run. So that's the equivalent of what is it the equivalent of? Good question. It would be nice to add tests here, wouldn't it? Script behaviors. I'm back in the days. And some tests here. And create or subscribe. No. This doesn't use event directly. Mouse get mouse. Yeah, it's I suppose mouse is yeah, it's here, and that I think uses the FRP event. It makes an event and subscribes to things. So the equivalent to notify, I think, is push, actually, isn't it? Don't we get okay, maybe I needed to look at the documentation. I forgot there were generated docs here. Poof. And I think maybe that's where things are. Push, yeah. So it gives us an event, and then we can subscribe to the event, providing a callback, and then we can push to the event. So it looks like it's been done in a slightly different way, right? Notify is actually not gotten from create, but notify takes a listener. So it's a slightly different way to move things around. I don't know which way would be better for us, but the interesting thing for us is to think about what would we do in our HTML DSL here. What would that end up looking like? We'd have on key up. And I think we would need to just maybe just So it takes synthetic keyboard event to effect unit callback. So basically the question is, could we do send here, right? On key up send. And maybe if we wanted, would say on key up, we would tag the event that we send. We could also make this a symbol like a singleton and somehow tag our counter, which would mean that our counter sort of handles, maybe the handles. On key up, handle on key up, maybe. If we, so I'm also a little bit thinking here in terms of ECS. It's like, are we, I mean entity component system, in terms of how do we consider, how do we decouple our components? And does this mean that we're kind of sending this into a bus and that we just label in some ways, and then some other part of the code is just going to consume that stuff? We can consume it. We don't need to eliminate it, I don't think, right? I mean, we could have different semantics, but possibly we could have several code registering to on key up, which is what makes me think about an ECS, because it's a bit like, you know, you create a global entity that becomes a kind of a bus inside your ECS, and you allow some events to write to it, and then you have your regular systems that will watch it and couple it to code and systems and so on. Okay, so we could start with something like this potentially, I suppose. And handle on key up. So handle will need to take a label, and then something would route, right? So here we're saying that this is handle, and this is really handler, even though it looks like this, but we're saying maybe we have a label somehow, and an M. And would that work? Maybe we need to do it like so. And could not match type string with Coty, blah blah blah, but that's because we have malformed code here, so we can compile. I see, so we've actually removed co here. Okay. And run co, okay. And handler. Ah, right. Yeah. Here we're trying to return a React class, and what's going on with that? Coty identity unit, a string. That's strange. You're saying that by passing string here, for some reason now I'm okay, maybe I need to do it like this. effect with type function string. Yeah, clearly that doesn't work as is. W unit string. Modify state and then a label. The type of pure component. This is hard to read. Render effect react element, but instead of effect, you have function string. Let's see. Extract state has this type. Right, it's because the handler type unit needs to have a label now. Is that gonna work? It is. It is gonna work. Okay, and so if that compiles, does this compile? Nope. Which I suppose kind of makes sense if I do it this way. So let's do it that way instead. See if we can get other types to align. Seems like we can, and right. So let's see whether doing that would work. I need to pass some m here, right? So okay, let's try with what we had before. It's handle right, so this, and then we get the same error. Okay, so I think that gets us back to where we wanted. Am I doing two things at the same time? I might be doing two things at the same time. I think I'm trying to decouple the handle somehow to create a kind of an event bus, and then I'm also trying to sort out this interpreter thing and where does the effect go. So yeah, indeed, that's going to be weird. Can I get the types to align again? I do still have Coty here, so maybe I should actually try should I try Coty here? I still get the feeling that that's the wrong way to do it, because it feels like with Explore M, we independent with a free with a pure co-free and a pure free, we're going to be able to pass some interpreter which is going to be effectful, and that's going to give us the effects we want. If we want this to be identity, then it's going to be identity, but that's kind of what I would prefer. So if that's what I would prefer, then in that case, we just backtrack on the Coty thing and we just say co. then based on that, we sort of go back to sort of the original stuff. And that I think means this, and that means counter interface counter model here, and it also means counter interface counter model here, and that means this right here, and then our interpreters are going to be right. Well, yeah, I mean, our interpreters are going to need to have some effects somewhere here, but right now we don't know how we're going to do that. Meaning we really pass this counter interpreter, which at this point doesn't do any effects. So I don't know how I'm going to be able to sort of am I going to need to pattern match on something there? I don't know. We will see. What does this say? Compose effect counter interface. Where is that still going on? Apparently here, for instance. I might regret this refactoring later, but it is what it is. Okay. Co-counter interface, co-counter interface, UI, co, blah, and inc is co-counter interface unit. And you say that you still want a compose effect counter interface for some reason. Also, you shouldn't need a monad anymore in the step. And I suppose I must have left counters is a list of counter space. Oh yes, of course, counter space still has the compose effect. That's what's going on. Okay, and then we don't have compose anymore, and we don't have pure anymore either. Yeah. And then we can't match list with functions. Okay, that's because I removed the passing of the interpreter here. Let's leave it for a sec. And counter cannot match co-free with function. Okay. Counter passes this interpreter. And so what's the dealio? Pass interpreter, and then we say list of co-free counter interface. And there's a co-t lingering somewhere. Probably in the component, to be honest. No, component is co now. So what is it? I'm using co, but from the co-t library, using co as co-tw identity. So is that what's causing problem? It might very well be. Function co-t function identity unit compared to co-free. And a string. Why do you want a string exactly? Okay, I am very confused. Very confused. We pass counter interpreter here. Is it a counter model to counter interface counter model? Counter model to counter interface counter model. Yes, it is. And so supposedly we try and pass it through here, but we are not succeeding. Diff prime should take an array of React elements. And somehow I think that counter interpreter is that. That doesn't quite make sense. Must have done a change here. Let's go back to main. No, not main here. Test main, I think. And our counters are being what's happening with our counters? The Kofi example is our counter, and we're just mapping we just list off diff prime store example, and that's what store is. And the diff button and store example is just this component, right? So we want a component here. What is and this is the same, and it's just a list of. Okay, so should I just do this? Good on my string. Where is string coming from? Function string. Could it be coming from the handler? Is my modification with the handler has somehow modified the... Yeah, that's pretty possible, because having changed the type of the handler means that any use of send is actually going to need a label. Huh. I hadn't thought of that, but yes. And so we'll call this push. Sorry about that. And that might not work with us. So that's a big refactoring. That's a big refactoring, because all of the handlers are going to take a string now, and we're not really ready for that. W and the type. Taking a natural transformation and doing some stuff with it, which might require to dig into this code here, which is not going to be easy. Could I transform the handler type in a different way? If it took a tuple, I mean, I would still need to go through all of the code and try and see how it's threaded. a list is what here? It's a list of some identity, blah, 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 day W, list W of A. So it's the second element of list that matters, the second argument of list, and that's the A. So so when we build it, our A is going to be the return type of lazy T. So when we build a lazy T, maybe we take another parameter. Oh no, this this differ. That's not kind of how it's going to work. But this, oh wow, this is pretty funky right there. Oof. Hold on, let's see here. Oh, it's that's where you can't match string. Where is C? Hold on. Did I just add that? Where is the C coming from? Doesn't make any sense. Oh no, it does. There's a C right there. So C is the component. And you're saying it should be a string. What if we say this? No. And what if we say this? Then you still have a problem right there. So when you day append, the f of x is this, and g of x, where is the day here? That shouldn't, I mean, yeah, actually the A is probably a return type for both W and list W. So I suppose it kind of makes sense that it would be unhappy both here and there. It doesn't make it easy. This thing is a real mouthful. Here f and xf. Those are a natural transformation from list W to W and list W to list W. Yeah, those feel very Comonadic. Maybe. That's extract in some way, I think. And so here being past the f, which is this natural transformation. Okay, is there another way to do this? Changing the handler type is obviously maybe a bit too difficult for me at this point. I mean, we'll try. We'll try again, but I just want to see whether I'm not seeing another approach to this. The reason why I wanted this label is to sort of route things, because if I don't route things, then I'm just going to receive. I mean, I'm going to receive sort of arbitrary m's in the CoW monad, and maybe that's enough to pattern match on things. Okay, let's revert back on this. Okay, so this compiles and this compiles, and this at least is not an error anymore, and we don't need a string here anymore. And now we also need to remove that. Okay, and now what? And now explore is a bit wonky because we're passing it an input, and that we shouldn't do anymore. And the list should also be not passed anything anymore. And now we are missing some. Well, we don't need any of that stuff anymore, and we kind of compile. Well, we haven't been compiling in quite a long time, so let's see whether we can actually do anything meaningful here. What's it's npm start. And yeah, 1, 2, 3, 4. And can we add counters? We can. And can we count? We can. Okay, so what have we gained? Yeah, I suppose I was putting this sort of here, I think, and then removing that. Is that right? Let's double check. Yeah, that looks right. And you're not going to shout that much as much. Good. So we're back to cows, and this thing is not in use, but for now we don't care. And then so what I want to try then is to say, well, we pass interpreters, so that's at least, I suppose, somewhat new. But I suppose we would want would we want this to be, in some sense, is that part of the semantics of the comonad? Whatever monadic context we execute it in. I don't know. This feels quite a lot that that's sort of a state. Is that just some store in disguise? Could very well be. in which case we could consider that that's just another one of the comonads that's sort of in the stack. And in which case we could sort of have it as part of the step and not do this anymore. And maybe just to make things just a bit tidier, do this, and then here we would actually go back to this, and we'll try to thread the not thread, but try to interpret in the yeah, no need for that anymore. Try to interpret in the Explorer bit if we can. So it could be that this sort of becomes our interpreter, right? We just need to maybe abstract over this modify state thing. I think that maybe that makes sense. State is gotten from here. So we're kind of saying, okay, that's interesting. I think we're saying that we have a handler, but now really it takes also state, which is what? Which is just component W. And it going to have to take this as well, right? This whole bit, whatever that is, as a parameter, some f. I'm going to say run f on that, whatever f is, and we'll try and pass f and state to our handler. And so what are we doing here? We're doing that, and yeah, this, and for W, and F doesn't have the right type. Yeah, because F, we don't know what the type of F is, but F is going to be the type of our modify state this blah. So what's that thing? It's something that takes a component W and I think returns an effect, I'm pretty sure. So an effect unit. because it doesn't. Hold on. It it's parameterized by this. So f takes this, but yeah, no, that's it. Oh. Okay, hold on. Runco m. Ah, maybe you need some. Yeah, you need to know that W is a comonad. And record with type function. So this might not work like this. We might need to name the parameter. You know what? If we can we pun? Oh, we can. We can, but it shadows, but it works. Holy what? Refactoring superpowers of functional programming languages. Amazing. Okay, fine. We don't pun. But it still works, and that is amazing. Because we've now our handler is quite generic. So the fact that Explore for React, you know, passes it a state and this kind of weird handler there, sure, it's a bit weird, but I think this is very generic. This is basically, but we can probably write it better. But so this is doing what? This is saying, you give me given an action, a current S, and you know what? That feels a lot like Explore M, doesn't it? We have something that returns an my, taking in the f. Yeah, no, except that we are not breaking down with the functor here. So that's actually, I think then it would be beneficial to use Explore M maybe. But so hold on, what are we doing here? We are with the S and the M, we're moving the S forward along M. And then we take something that is going to take the result of that and do whatever it needs to do. They're supposed to move forward, right? So it's sort of is it like actuator in Reactimate or something? For some reason, I'm starting to see some FRP here. I think Reactimate these days was in maybe, weirdly enough. Maybe not. There's a Reactimate maybe. Except let's Reactimate B. Reactimate really only takes the MSF. So maybe I'm thinking of like examples, like bouncing ball or something, and some arrows. Reactimate. Yeah, that guy. So where? I think maybe it's in Yampa. It's in Bear River, therefore. Right, sense, there we go. Sense, actuate, sense initial, sense, and then actuate. And actuate receives the payload of B, which is sort of the post. I mean, there's different ways to say it. You could say, receiving the M is the thing that sort of terminates the arrow here. Or because we're also passing, yeah, like, because in the way that it was written before, it's a bit like we're passing the comonad along as state, because that's, at least with React, that's the way that you trigger refreshes. But is it more relevant to imagine that actually what's flowing through is the monadic actions? Kind of is, isn't it? Because DOM and the callback and this whole send malaki, that's kind of sending an M through. So actuating would be receiving some M and receiving something in a base monad. Like so. Oh, except here we pass the component. Do we even need to pass the component? We do, but that's just in this case because we might want to persist state. Or we want to persist state in React. Yeah, we want to use React and allow it to manage the state. So there's an argument that this is previous state. And that F is kind of store or like modify state or something like that, right? It's persist, maybe. Persist, actually. So save, actually. And so this is saving. Okay. Handler takes the previous state. Is it? Hold on. No, it's not the previous. No, it is the previous state. Yeah. Previous state. Advances it along the monadic action M. And saves the result. Is that how close is that? Because there was a write, I remember now, in and maybe calling it write is actually pretty good. And now it makes me think of Arthur Xavier's formulation, which used write pretty much exactly in that way. So I'm glad we are definitely going in the same direction. But hold on one second. Let's compare a bit more. what's going on here. So I think, yeah, this is sort of explore. So he has write before and space after, and then extract space of a thing, which will write eventually. Okay. And then in the React implementation, he uses explore but passes. Look at this. S to our modify state this blah. So right, instead of modify state, he uses write state, but that's pretty much exactly the same thing. And he passes this to explore. So he does the extract state thing in what we call handler, which kind of makes sense, right? It kind of makes sense. So let's call this React Explorer. And let's call this Explorer. And then we do explore here. And then we do extract. What was it? Extract state. And then we could say send, and then let's send equal. And send would be a handler. That makes sense. Handler of co-w unit. Is that right? Mismatch indentation. Oh yeah, where? Maybe. Yeah. Yeah, it's not state, it's prev. Does it use state in two places? I call it space here. Space, yeah, move space, which is our extend const prev. Sure. It's really the current state. So takes the current state, advances it along the monadic action and says the result. So oh, except this is now explorer, right? But without extract state. So we can do pure blah and remove a couple of parentheses, right? Except it might need to be pure here. Handler. Oh, send M. Right, where is the... Ah, yeah, you do, you put your M in there. That's really interesting though, right? Like how the base is used here. Actually, I mean, you call it base. Yeah, I don't really know what that's supposed to be doing, right? Yeah, no, it extracts the... It extracts the M from the base. It extracts the action from the base monad after executing the thing. So I think that's fine-ish if you want to put your if you want to be able to put monadic actions in the sending, but that's not really an interpreter, right? So I think well, function called blah. How are we going to do this? Extra state send. Yeah, you know what? I think that's not exactly equivalent. But maybe it's just that this type is not the right type. Explore blah. Yeah, maybe it is not taking an M. And however, this is taking an M. And yeah, state component. Yeah, so you're not taking a codable unit anymore? That sounds a bit weird, but it's possible. And what's going on here? React element with effect unit. Right. Yeah, then the return type would be different. I think I did too many changes here. Return type here is A. A being the carrier type that we don't even have here. I mean, I suppose we could say for A and add the A to the component W, component A there, but that feels strange. But in any case, you want a React element. You don't even want a React an effect. No, you get a React element. But I don't want to return a React element here. So it's true that if I want to keep that, yeah, given how the abstraction is done here. Yeah, A is the React element. Okay, so I suppose we could say handler, A is action, right? So handler action. Okay, let's do a little bit towards this and say fine, we'll make this polymorphic in A, and then we'll say, you know what, we say that a component is has React element, and that should allow us to okay, maybe not, maybe A, and then in React Explorer we'll say component W React element, but here we'll say WA and we'll say WA and we'll return A, and that works. And I'll Okay, well, that's going to be all for today. Let's just check whether this, because it compiled. So does it work? I mean, usually in, hey, no, it doesn't work. Okay, that's pretty cool. Okay, so next time we'll just try and fix that. Interesting, it's just not working anymore. So I must have messed something up. And oh yeah, of course, React Explorer. We need to use React Explorer here now. Let's just change that and see whether it just works or not. And we need to export it and import it. So that's going to come from, where do we have Explorer here? Here. And hopefully it's imported. And no, we have some more errors. Well, we'll solve this next time. Thanks a lot for watching, and bye-bye.